38 people are here. So let me start with today's lecture. Very important lecture, very important lecture, because these are some fundamentals which is very useful. You will be finding this is we are going to start with signal flow graph. And I told you last day that the block reduction technique is a very big process, and step by step you have to come to the final transfer function diagram. But the same transfer function diagram you can find out by signal flow graph in one shot. That is, only in one line you can write down what is the transfer function of a big system. But while doing in the exam, you do it the way I am doing, for the at least for the initial numericals, the way I'll be doing. So every small step we have to show. Things are very easy, but it's having a certain logic, and that logic you have to understand. And if you are listening it from me and then trying to do it, it will be very easy. So that's why everything is given in the book. If you can read from the book and understand everything, there is nothing better than that, and a teacher is not required that way. But our job is to concise the thing, to make the thing smaller and present things in front of you in an easier manner, so that understanding process becomes easier and less time consuming, because time is a very big factor. So that's what I had posted that message, that everybody should attend at least today's lecture, because main structure of signal flow graph we are going to do today. Only one variant will be remaining, only one small part will be remaining. That part we will be doing on Wednesday. So there are mainly one type of numerical, but I divide the numerical into two parts. One part, what we are going to see today. Another part is if there is some non-touching loop which is not touching the some forward path, then what to do. So only one constraint will be remaining after today's lecture. So mainly there are two types of numericals are asked. One type we will complete today, and another type we will see on Wednesday. So by Wednesday you will come to know everything, all the processes, all the procedures about signal flow graph. And there are innumerable number of numericals. Any book you open, 50 different numericals you will be finding. And I have found a book, from there I'll be doing it. So I've directly cut pasted that images in here. So those numericals also I'll be posting. Main job is onto you, that you have to keep on practicing. Okay, so there are a lot of numericals and you have to practice. Ek din practice karo bas. Just give 2 to 3 hours and you are securing this 10 to 20 marks in the end some exam. So same, so this chapter is highly scoring. Okay, so you should score 20 out of 20 in module 2, block reduction technique, signal flow graph. What all maximum difficulty level we are doing, we will be doing it. So whatever numericals we have done in block reduction, that will be the maximum level of difficulty. Now there are some variations that in block reduction also we have not seen. If instead of one input, if there are 2 3 inputs, then how to do that. So I don't think that kind of numerical will be asked in your final exam, end some exam. But yes, those kind of things you should know. And in GATE exam, they ask that kind of numerical. That is, if more than one input is there, if more than one output is there, then how to proceed and how to find the transfer function for that kind of block reduction. So 1 hour of session I will not do live, but I will record some 2 3 typical difficult type of numerical in block reduction, and I'll upload and I'll send you the link, so that I can do anytime within this week. I'm having planning to do that. And one thing is very big important thing remaining, that is numerical on 30. So whether we will do it live or again I record and upload to you, so that I'll let you know. But yes, lot of numerical have to be solved on module 1. Okay, so let us start with the signal flow graph. I think 43 people are there, quite good. So there is something called a signal flow graph. Whatever block reduction big diagram they used to give and used to find the transfer function, here also the same diagram I might give. Or sometimes what happens is, if the examiner wants to reduce his work, he will give the same block diagram, big block diagram. He will ask question number 1 solved by block reduction technique, question number 2 solved by signal flow graph method. Answer will be same, process will be a little different, and signal flow graph is little less cumbersome. Okay, so इसमें तकलीफ थोड़ा कम है, काम थोड़ा कम करना पड़ता है, but signal flow graph requires a little bit more understanding. Okay, so what I find is block reduction technique does not require much understanding, but it's a more of a rigorous kind of a thing. Just keep on solving loop after loop, loop after loop, likewise. But signal flow graph requires a little expertise, and whatever expertise are required, I will prepare you for that, because it is only some different types of numericals. So I prepare you with that, and nothing will be unturned. So please prepare all the numericals which are either being done in here, that is in the lecture, or is being given as your homework. So some homework I'll give today also, one numerical, or which I am recording and giving to you. So all numericals, either in the form of notes or in form of live lecture or in form of homework, whatever is being given. So every numerical is different. Every numerical is having a different flavor added to it. So please do all of them. So you can find here, this is a second topic, Mason's-Gain formula and signal flow graph. So signal flow graph is actually being executed by Mason's-Gain formula. It is also called MSG formula or something. It's very simple, but that question, again, if you're having pen and paper, write that thing down, that write down the Mason's-Gain formula and explain each and every term of Mason's-Gain formula. That can be a 5-mark theory question. Again, I'll repeat, explain Mason's-Gain formula. So there is nothing to explain as such. You have to just write the formula, and you have to write down what are the different parts of it. So there are some 4-5 different areas in the Mason's-Gain formula. Each one what? Okay, so that you can explain, and that is actually asked for a 5-marks question. That is the only theoretical question that may be asked here. Others all are numerical. And there is a self-learning topic towards the end of the syllabus. So tomorrow's lab we will try to do in that line, that is determination of system impulse response and step response for transfer function evaluated by block reduction or signal flow graph. So for small system, big system, we have found out what is the transfer function. So that is ys by xs, that is output by input, is equal to transfer function. Then after that, how can we use the transfer function to find out what is the impulse response or step response? What is my impulse response? Ys by xs. Instead of xs, you substitute the Laplace of impulse. So Laplace of impulse is equal to 1. That means ys by 1 is equal to transfer function. That means ys is equal to transfer function. So how to find yt from ys? Take inverse Laplace transform. So the process is ys by xs. Then substitute xs is equal to 1 if the input is impulse, because delta t Laplace transform delta t is equal to 1. Then find what is ys. So ys is equal to the transfer function itself. Then find yt. That means whatever transfer function you have found, take the inverse Laplace transform of that. That is called as yt. That is called as impulse response. What to do in case of step response? In case of xs, substitute 1 by s. So ys is equal to xs. Xs is nothing but y 1 by s. So ys is equal to 1 by s into transfer function. So now you have to do something called as partial fraction, and after that you have to find the inverse inverse Laplace transform. That is, you find yt, and what is yt called? Yt is called as a step response of system. So all those things we'll be doing tomorrow, and tomorrow's lab is also very much interesting. There will be small code, but there will be a lot of cases that we will be seeing. And we'll understand the concept of stability. What is the different pole position? So depending on pole position, what is going to be its response? All those things we are going to see tomorrow. So please join on time, exactly at 10 o'clock, and open your MATLAB window and wait for us to start. So codes will be small. I'll send you the code today itself or tomorrow. But tomorrow's lab is very important. It will be interesting. And a small code. So those who are doing with mobile and all, they also will be able to execute. So things will be very small, but there is a lot of understanding that we will see tomorrow. Okay, so let's start with signal flow graph. So this is what is called as a signal flow graph of the block. I think the slide is visible and you can read it. So it is saying that whenever a block diagram is given, so this is a block diagram of a closed loop system, we can convert it into a signal flow graph. What main things we are supposed to see here, how many such node dots are there? So how many nodes are there? So here, this is one node where two inputs are there and one output is going out. So this is called one node. So here, this is the node. Okay, name you give, it's okay. Even if you don't give any name, it's okay. So it is between RS, ES and BS. Okay, so this is RS, this is ES and this is BS. Not necessary you have to give any name. Okay, so after this node, so this summing point is acting as a node. And this point is also acting as a node. What is this point? CS is going out and one thing is coming in, and this feedback is coming out. So this is a 3-point node. Input is also a 3-point node. So you can find here, this is also a 3-point node. From here, you can show another arrow outside from CS, another arrow right side, and you can say this is the output. So whenever there are 3 points mixing up, okay, 3 points getting mixed up, you can say this is a node. So this is a system where there are three nodes. Sometimes 2 point getting mixed up we call as a node. So this is the first node and this is the second node. So wherever node is there, you have to represent that thing by a small dot like this. Okay, and between RS and ES the gain is 1. So this is gain 1. Between this node and this node the gain is G. So between this node, summing point node and output node, the gain is G. That's why this arrow is there. Direction of arrow is very important, and this is G. And from this CS to this input node, so from input to output node, the gain is G. From output node to input node, there is coming a feedback path, and that gain is given by H with a negative feedback. That's why it is called as a minus H. So be very much observant. What are the things to observe? That what is the direction of the arrow? So here between input node to output node, direction is left to right. That means this is called as a forward path. Okay, and something is called as a forward path gain. So how much is the forward path gain? It is 1 into G. That is forward path gain is capital G. And how much is the feedback gain? So first you have to find what is the loop. Okay, so this is G and minus H is the loop. So there is something called as a loop gain. Okay, so how much is the loop gain here? It is called as G into minus H. So loop gain is equal to minus GH. Now there will be complex processes where there will be more than one loops. There will be non-touching loops, there will be touching loops, there will be overlapping loops. So all those things you have to understand. So this loop gain is called as minus GH, and feedback gain is called as minus H. It is actually H, but it is having a negative feedback of minus. So that's why you can say that this is minus H. Because in signal flow graph there is nothing called a summing point or something. They are called nodes. So here instead of ES, in place of ES you cannot write plus or minus as you had been writing in case of summing point. So directly in feedback element only you have to represent what is the feedback. So this is minus H means this is a reverse feedback path. So let us let us read what they're saying. SFG or signal flow graph is a graphical representation of the system equation, and in this sense serves as the same purpose of block diagram. That is, we find transfer function. Unlike block diagram, which consists of blocks, signals, summing junctions, and takeoff points, so here all these things are not there. A signal flow graph consists only the branches which represent system and nodes that represent signals. So at node we can find out how many input signals, how many output signals are there. So figures show a simple block diagram and equivalent signal flow graph. So I told you that examiner wants to reduce his work. So one big block diagram he will give, and he will ask find transfer function by using block reduction technique. That can be question part A. Part 2 can be convert this block diagram into signal flow graph and find out the transfer function. So that is another trick, how to convert a signal flow graph, sorry, how to convert a block representation into signal flow graph and then perform the operation of finding transfer function. So all these things I will teach you, so don't worry, it's very easy, but you have to be observant. That is the main thing. Okay, the tiny circles, so these are the very tiny circles, small one. These tiny circles are called as nodes and they represent three key variables: RS, ES and CS. So RS, ES and CS means what is coming in, what is coming as feedback, and what is going as output. So every node might be having these 3 points. Sometimes more than three elements can be also connected in one node. So there may be more than two inputs, there may be more than two outputs possible. Okay, so that directed line segments show the relationship between the variables, including the appropriate transfer function. Here you can see G is the transfer function. The expression for a variable at a node is obtained by ES. So how much is ES? We have seen that ES is equal to RS minus BS. So here the BS is not there, so we can say that RS minus CS into H. So CS is coming back with a feedback gain of minus H. So it is RS minus of CS into H, that is equal to ES. So that is the same thing they have said here. In the last line you can find ES is equal to, that is error signal is equal to RS, that is the command input or input to the system. Now this system, if it is, sorry, if this input is impulse, it can be step. Okay, so whatever error you are finding, that can be with respect to impulse, that can be with respect to step. So if it is impulse input and you are trying to find the error, it will be 1 minus C into CS into H. If it is step input and you are finding error of the system, it will be 1 by S minus CS into H. This is a very important thing, that as input changes, the error function also changes. The output function CS also changes. Okay, and CS, if we know CS, how can we find CT? CS is in Laplace domain, so take the inverse Laplace of that, you are finding CT. CS can be YS, okay, a representation, or CT can be YT. So this is where you can understand that is error is equal to RS, that is input. So if input is impulse, error equation will be 1 minus CS into H. If input is step, that is Laplace transform of step is 1 by S. In that case, error will be 1 by S minus CS into H. And depending on that, you can find error in time domain. So ES, you know, you take the impulse Laplace, inverse Laplace, and you're finding ET. So all these things are there, can be found. Now the expression is nothing but the output of the summer. Okay, shown in a previous page. It may be noted that with signal flow graph, negative summation is designated by the use of a negative sign with the appropriate transfer function. That means whatever h is there, this is shown as minus h because this h is connected to a negative feedback. Now similar to the block diagram, signal flow only in one direction, arrow. So from left to right, we are showing the forward path. Now some important definition. This is another signal flow graph. Okay, so first thing you are finding here is how many forward paths are there. Now here you concentrate. There are a lot of things we have to understand. How many forward paths are there, and be very careful about the arrows. Okay, so how many loops are there? You can find out. So there is only one loop. Okay, loop means starting point and end point are same. So this is one loop. Starting point and end point are same. What is the starting point and end point? This thing is starting from this point, is starting from this and coming back through. So one loop gain is minus G2H1. This is one loop gain. Another loop gain will be minus H3 into G2. Another loop gain is minus H1. So this is something you have not seen in block diagram. This is called self loop. Starting point and end point is same with a negative feedback. So exactly what kind of circuit is giving you self loop, we will discuss later. Okay, so this is also called as a loop. You can say starting point and end point is same. But everywhere starting point and end point is same. You can see here. In this loop also it is starting at this node, going forward and coming back. Here also starting at this node, going forward and coming back. So it is minus H1 G2, it is minus H2 G3, it is minus H1, sorry, minus H3. Okay, so don't worry, even if it is very small, don't worry about that. I will post you all the slides. You'll be able to see what it is. So these are loop gains I'm talking about. This is easy to understand. What is forward path gain? So there are two forward paths. One is G1, G2, G3, G4 gain. So that is what they're saying, P1. So P stands for the gain of the forward path. It is G1, G2, G3, G4. This is the forward path gain. So this is the first thing you have to find out in case of any signal flow graph. How many forward paths are there? Second thing, G1, G5. You are finding that there is another forward path whose gain is given by G1, G5. Okay. So a forward path is a path from input node to the output node that does not enter any node more than once that follows the direction of the signal flow. The forward path gain is defined as a product of gains in the forward path. So here we are finding there are two forward paths, G1, G2, G3, G4 and C. So between R and C, this is one path. And between R and C, there is another path. Okay, so like this. In forward path, you cannot take the feedback. So G1, G2 minus H1, G2, no, it cannot happen because forward path cannot touch one point twice. Okay, so it will go in the forward direction only. Okay, you don't include the feedback in that. Okay, so likewise, so there's a comparative simpler fundamental. Now this is the most important slide. I'm telling you, there are a lot of things that I will explain with respect to this point. So loop or individual loop gain. Okay, so individual loop. So first point you have to find out is how many forward paths are there. That is the most important thing. And one term you are not able to assume pura transfer function galat ho gaya. Okay, that's why your observation should be very strong, and you can make your observation strong only by repeated practice, or you have to do many numericals. Okay, time karte karte aaram se samajh jate, it is difficult, but observations will be strong. Okay, so G1, G2, G3, G4 is one forward path. G1, G5 is another forward path. The signal flow, we find there are three individual loop. What is the first loop? Loop gain. L stands for loop gain, individual loop gain. Okay, so this is minus G2H1. Second loop is minus G3H2, and third loop is minus H3. Okay, so यहाँ तक easy है. First one is find forward path, how many are there. Second one is how many loops are there. Then you have to find how many two non-touching loops are there. So this is a small system, that's why non-touching loops are there. So sometimes there will be two non-touching loops, sometimes there will be three non-touching loops. If the circuit is very big or system is very big, there may be four non-touching loops. So just check what are the loops. So three loops, then check whether loop 1. So loop 1 and loop 2, they are touching or non-touching. We are finding they are common to a node. Okay, so loop 1 and loop 2, L1 and L2, they are touching. Okay. Loop 2 and loop 3. Okay, so this is loop 2 G3H2 and loop 3 is minus H3. They are also touching, and this is the node where it is touching. But you can find that L1 and L3 are called as non-touching loops. So that is what they're saying. Non-touching loops are the loops that have no common nodes. Okay, so loop 1, that is minus G2H1 and minus H3, they are non-touching loops. So in the representative signal flow graph, there are two loops, that is loop 1 and loop 3. They are called as non-touching loop. So how to find the gain of the individual loop? Minus G2H1, this is minus G3H2, this is minus H3. So this is the second part. Third part is find how many pair of non-touching loops are there. So there is only one pair of non-touching loop in this system, that is loop 1 and loop 3. Multiply their gain. This is the next thing you have to do. So that I have shown in the next slide. Okay, what is the input node? Input node is RS. What is the output node? It is CS. Now check. I have shown. So I told you this is the most important slide. Multiplication of loop gains of two non-touching loops. So this minus G2H1 and minus H3, they are non-touching loop pair. So they are pair which are non-touching. So in that case, multiply their gain. कहाँ पे use होगा? That I will tell you during we are solving the big numericals. So this non-touching loop minus H1 G2, another non-touching loop is minus H3, multiply their gain. So what it is becoming? Minus H1 G2 into minus H3, this is becoming H1 H3 G2. Okay, such if there was another loop here non-touching. Okay, in that case, this and this non-touching loop multiplication, this and this non-touching loop multiplication, all would have been added here. Okay, so we'll see a big numerical where such cases arise. But in this numerical, there is only one pair means two. Okay, one pair of non-touching loop, that is L1 and L3, multiply their gain, and this will be used in transfer function. Then the most important thing, which students cannot understand. Okay, and it is not difficult, but it is only a observation. Check this forward path. Okay, G1, G2, G3, G4, it is touching all the loops. So first, how many loops are there? L1, L2 and L3. And you are finding that this forward path G1, G2, G3, G4, it is touching all the loops. So कोई लफड़ा नहीं है, no problem. But you are finding that this G1, G5, it is not touching this H3 loop and this minus G3, H2 loop. Okay, what I said, this forward path G1, G2, G3, G4, they are touching all the loops. Okay, hence no problem. But you are finding that some forward path is not touching some loop. Okay, so this G1, G5 is not touching this minus H3 loop. This G1, G5 is not touching this minus G3, H2 loop. So hence there will come a term. Okay, so in the numerator we write what are the additions of all the forward paths. So whenever you're writing all the additions of forward paths, so first you will write G1, G2, G3, G4 plus G1, G5. But it will not be only G1, G5 because G1, G5 is having non-touching loop of minus G3, H2 and G1, G3 also having non-touching loop of minus H3. So with G1, G5, one term will get added. What is that? It will be 1 minus. So G3, G5 is there. It is a non-touching loop. With that, there will come few more terms. So 1 minus. 1 is from the formula. Minus is also from formula. Then all the individual loops and their gain. So 1 minus. So G3, G5, this is a forward path. Bracket 1 minus bracket addition of gain of all individual loops. So what is the addition of gain of all individual loop? This thing is minus H3 plus minus of G3, H2. So this is another term which will come in the numerator. So if you're trying to find the transfer function of this, what will be there at the numerator? First term will be G1, G2, G3, G4. That is the first term. Plus. Second term is G1, G5. So at numerator, we write all the forward path gains. Okay, so one forward path gain is G1, G2, G3, G4. That will come in the numerator. Plus another forward path is G1, G5 plus G1, G5. But G1, G5 will not come alone because G1, G5 forward path is not touching these two loops. Which two loops? G3, H2 and H3. This G1, G5 is touching this G2, H1. Okay, hence G2H1 will not come in addition within this block. So G1, G2, G3, G4 will be multiplied by 1 minus addition of all the non-touching loops for this forward path. So this is some concept which students don't understand, but it is very simple. Write the forward path, that is gain G1, G5 multiplied by 1 minus of all the non-touching loops. Okay, so here there are two touching loops which this G1, G5 is not touching, hence their gain will come inside this bracket. So I will write this transfer function G1, G2, G3, G4 plus G1, G5 multiplied by 1 plus H3 plus G3, H2, because all this minus will come out and they will get plus. So G1, G5 multiplied by this plus G1, G2, G3, G4 will be the numerator. So this easy is this numerical. Okay, then what will be the denominator? So how to find the denominator? For that we will have to see the next thing. So forward path G1, G2, G3, G4 is touching all the individual loops, hence the term G1, G2, G3, G4 will appear directly as it is in the numerator. This will not be multiplied with 1 minus something because it is touching all the loops. So whichever loops it is not touching, some loop, some forward path is not touching, a bearing of that will come with this forward path gain. Okay, so abhi thoda difficult jayega samajhna, but as we keep on doing it, we will understand. So let me solve one or two numericals, we'll understand this fact. Okay, now this is Mason's gain formula. So totally you will not understand now, but as we keep on doing numericals, we will understand what is it. So Mason's gain formula is used to find the transfer function CS by RS in signal flow graph. An advantage of Mason's formula is that system transfer functions are readily obtained. That means in one shot you can find what is the transfer function. So CS by RS is transfer function PK. PK is the gain of forward path. So just now in the previous numerical you had found this is G1, G2, G3, G4. This is P1, that is PK1, or G1, G5. This is also can be PK. What is delta K? Okay, so delta K I was explaining to you. Delta is determined as a graph 1 minus loop gain. Okay, so here you found only there are single loop gains because there are no two non-touching loops. Hence, I wrote only 1 minus of minus H3 minus G3H2. Okay, so that's why delta K is given by this. And denominator delta K. So how to find denominator delta K? Again, there comes this thing. That is how many single non-touching loops are there, how many pairs of non-touching loops are there. If there are 3 loops which are not there in a transfer function or in a signal flow graph, their loop gain has to be multiplied and it will keep on going. So what are all these terms? I cannot explain to you now, but we do numerical and we'll understand, and again we'll come back to Mason's gain formula. So we have to solve a very big numerical to understand each and every part of Mason's gain formula. कितना भी theory पढ़ाओ, Mason's gain formula नहीं समझता है unless and until we are solving a numerical. Okay. So now we will solve a numerical, and we'll start with my numerical. It's an easy numerical, and almost it looks like the same numerical which what we have seen. So just see that this is the path. So this is the first numerical we are solving. We'll solve 2 numerical and 1 numerical I'll give you as a homework. And Wednesday when we are starting, maybe we will start with the solution of that. Actually, I have told you to submit the homework numerical by today 10 o'clock. You submit, so write it down in a page and scan that page and submit it in our, that is division A Google Classroom. So I will create the instance, so that will be some 5 marks will be assigned to it, so it will be a part of activity. So you have to solve this numerical, third numerical, whatever is given. You make mistake, doesn't matter. Okay, so how much you get out of 5 is not important, but you just give a try and you solve it and submit it. So today only you solve it, scan it, upload the PDF into the individual. So except the experiments, everything else have to be submitted in our private Google Classroom of A division. So this solution also you have to submit our private A division Google Classroom. I will create the instance. I'll give 5 marks for that. And today also only I will check it. By tomorrow we'll get the result. Okay, so 2 numericals we are going to solve now. Another 20 minutes is there. So 10 minutes per numerical. Let's see. And if you are having any doubt at any time, please ask me question. Okay, it is easy. Samajhta hai. So just check the arrow. So how many nodes are there? 1, 2, 3, 4, 5, 6, 7. There are almost 6 nodes. Left side is RS, right side is CS. How many forward path? Okay, but before that, let us see what is G1. So this is is a loop. Always check the arrow. This is a loop. Okay, so two loops. First loop is minus g1 h1. This is the first loop. This is not a loop. Okay, g1 and g2, you check that this is forward direction, g2 is forward direction, g3 is also forward direction. Okay, so how many forward paths are there? First forward path is g1 into 1 into g2 into g3 into g4. So first forward path is g1 g2 g4 g5. The first forward path is G1, G2, G4, G5. Be very careful. G3, G2 is not a loop. Okay, G3, G4 are two parallel paths. Both are going from left to right. Okay, whereas if you see G1, H1, it is going forward and coming back. If you see G4, G5, H2, they are forming a loop. Okay, so this is loop 2. So this is, I call it loop 1, L1. This is, I call loop 2. So what is the loop gain of loop 2? It is minus H2, G4, G5. It is written here, minus G4, G5, H2. What is the second forward path? It is G1, G3, G4, G5. So, okay, so I'm giving you 30 seconds to understand this, whatever is given here. So four things are given here. Two forward paths. First forward path is G1, G2, G4, G5. It's all going from left to right. Second forward path is G1, G3, G4, G5. So this you have to understand. This is the first thing. And second is there are two loops. Minus G1, H1 is loop gain for loop 1, and minus G4, G5, H2 is the loop gain for loop 2. And we find that loop 1 and loop 2, they are non-touching. So we can find out if they are non-touching loops, multiplication of their loop gain. So this second loop and first loop, they are non-touching. So another term is there in the denominator, that is multiplication of loop gains of two non-touching loops. Then plus multiplication of loop gains of three non-touching loops, minus. Then plus multiplication of four non-touching loops, and it will keep on going. Okay, but generally those big circuits we don't have, those big systems we don't have. So generally here for this numerical, only up to two touching loops, because there are two loops and both the loops are not touching. So there will come, which I have shown in the next page, that term will be this loop gain and this loop gain and their multiplication. Why? Because they are not touching. If they were touching, then that term would not have come. Okay, so they are not touching because two nodes of this thing and two nodes of this thing. So there is no common node. Hence we have to say that loop 1 and loop 2, they are not touching. Hence their loop gain is multiplication of minus G1 H1 multiplied by minus G4 G5 H2. So multiplication of loop gain of one pair of non-touching loop is G1 G4 G5 H1 H2. That I have shown in the next page, but at least I'm giving you 30 seconds to understand whether you know what is P1, P2, whether you know what is L1, L2. Only check the arrows and confirm yourself. So I'm giving you 30 seconds time. If anybody says, sir, I have understood, please write down, or please say, sir, I have understood. Yes, you can go forward.
Yes, sir.
Understood, sir. Okay, Kiran says non-touching. Non-touching means this loop is starting from here. Okay, this first loop is starting from here, G1, and it is getting completed here only. So it is only this much part. It is only this much part. Okay, it is not touching. Just see that this part and this. So if it was a loop, okay, G2, G3, instead of G3, it was a feedback. Suppose minus H3. Okay, thank you. Those who have understood, it's okay. Suppose it was a loop. Okay, instead of forward, this was a reverse. Just assume this was minus H3. In that case, this loop and this loop would have had a common node. Okay, this node is common for this loop and this loop. If it was a loop, it is not a loop here. Okay, in the previous case, acha chalo ye dekh lo. In this case, this G2 and G3, they are touching loop. You are finding they're touching loop because this node is common for this loop and this loop. But you are finding that this G2H1 and this H3, they are not touching loop. Okay, because here this node and these two nodes, don't see this part, don't see this part, don't see this feedback path, only see the nodes. If these nodes are not common, so if two loops are having a common node, then we call those two things as touching. So here this loop is only for this node, and this loop minus G2H1 is having these two nodes. So is there a common node between this H3 and G2H1? No, there is nothing common. Hence, this H3 loop and G2H1 loop, they are called as non-touching loop. Don't say that, sir, it is connected by a feedback path. We don't consider feedback path. If there are common nodes, then we call those loops are touching loops, like this. Okay, so in this case, these are the two nodes defining this loop minus G1H1, and these are the three nodes defining this loop, that is this and this three and these two, they are not touching each other. Hence, this initial loop minus G1H1 and the latter loop minus G4 G5H2, they are non-touching. Kiran, can you respond now? So understood somewhat. Let me solve some 2-3 numericals, we will understand. So just see, there should not be common nodes. Okay, there should not be common nodes. In that case, we are saying that they are non-touching. So I think this is understood. So there are two forward paths and there are two feedback paths. There are two loops. Now there is another thing. What is there? That is, just check this part. Just check this part. So this is actually what is Mason's gain formula. So forward path gains. What is forward path gains? Previous we have seen that G1, G2, G4, G5. So this is transfer function directly. You can write down G1, G2, G4, G5 plus G1, G3, G4, G5. So ये हो गया numerator. ये हो गया numerator divided by 1 minus. So in Mason's gain formula, I told you I cannot explain delta to you if I don't do a numerical. So now I'm telling you what is delta. ये सबसे important से देखो and concentrate. 1 minus, this 1 and minus is a formula, and this plus is also a formula. So 1 minus plus, they are of formula. Then comes bracket, first bracket. What it says is individual loop gains. Here it is said that summation of individual loop gains. So how many loops are there? First is minus G1H1. So I'm writing minus G1H1. Please don't make mistake in symbols. You make a lot of mistake in symbols. So numerator, just see what are the individual loops. So there are two forward paths. There is no loop in the numerator, only two forward paths. So they are added. Okay, and denominator, and both this forward paths are touching all the loops. So in that case, this example is easy. Okay, so 1 minus, this is 1 minus is a formula. Then whatever individual loops are there, their loop gain addition. So what is the first loop gain? Minus G1H1. What is the second loop gain? Minus G4 G5H2. So okay, because there are only two loops, that's why only two terms have come. Then plus, if there are non-touching loop, there will be a lot of numerical where there are no two loops which are non-touching. So in that case, you can stop here. 1 minus addition of individual loop gains and their summation. Khatam numerical. Okay, simpler systems. But if the system is more complex as this, we are finding that these two loops are non-touching. In that case, plus multiplication. So it is written here, plus multiplication of loop gains of two non-touching loops. So in that case, plus multiplication of loop gain of two non-touching loops. So what is the first loop? Minus G1H1. And what is the second loop? Minus G4 G5H2. Their multiplication. Now you simplify it. So numerator is G1 G2 G4 G5 plus G1 G3 G4 G5 ho gaya. Denominator, so this minus you can bring out, so it will become 1 plus G1H1 plus G4 G5H2 plus multiplication of loop gains of these two loops. So this is G1 G4 G5H1H2. Khatam. So in one shot, you can find out what is the transfer function of the whole system. So what is the numerator? Numerator is nothing but the addition of all the forward path gains. So here there are two forward paths, and forward paths are touching all the loops. So that's why there is not coming any separate term here. If there was a forward path which is not touching two loops or three loops, in that case, the numerator term will be more complex. Okay, we will say you that. And denominator 1 minus addition of individual loop gains plus addition of all the two loops which are not touching and their multiplication. So this is the formula for Mason's gain formula. Forward path gains 1 minus summation of single loop gains plus multiplication of loop gains of two non-touching loops minus multiplication of loop gains of three non-touching loops plus multiplication of loop gain of four non-touching loops, and so on. Okay, so when we do bigger numerical, we'll come to know about it. They're very simple numerical, and as soon as I give this in one shot, you can write this. But ऐसा लिखने से नहीं चलेगा. In exam, you have to show all the steps. That is, what is the forward path gain, what is the forward path which is non-touching, what is the feedback path, and what is the loop gain, how many loops pairs are there which are non-touching, what is the multiplication. If there are three loops which are non-touching, in their case their multiplication, all this, then you have to write this formula, then step by step you have to build up CS by RS, and then you can say this thing.